the last lecture, that was the very first lecture where we talked about what object-oriented programming is. We compared it to procedural programming. So, say one of the examples of procedural programming is C, right? So, where everything needs to be written in the form of functions, which is nothing but a procedure. And in the object-oriented programming, we talk about classes, objects, and the message passing between the objects, which happens through the methods. We also talked about attributes, which capture the state of the object. Right? So we also briefly look.
Excuse me, sir.
Yeah.
So can you explain encapsulation again?
Sure. Okay. So encapsulation is nothing but wrapping, right? So to encapsulate something is it means it's just a wrapper or something. So let's say you have your phone. So if you remove your phone cover, then you can see all the circuits and all electronic equipment that makes up the phone, right? But once you put the wrapper on top of it, you won't see any of those details because they are unnecessary for you, for the common user. And it will only expose the interaction points, so to say. So the only way to interact for you with the phone is through the touchpad. That's the first interaction point. And the other one is through these plug points. So you can, in order to charge it, you need to insert the cable at a certain place in the phone. And the other way is probably for the earphone. So you have a slot for the earphone. And then you may have a slot for the USB cable and so on. So there are very specific ways to interact with the phone once the encapsulation is put on top of it. So it is meant to hide those kinds of implementation level details which are not required for everyone, right? So if we use that, so object-oriented programming makes use of this encapsulation, and it is done through. So in this case, we encapsulate the methods and the attributes, and the wrapper here is the class. So we put together related, say, responsibilities, so to say, and then we wrap it up using the class. So let's say there's a class of student. There's a class called student. So student would have attributes such as, say, roll number, the batch that the student joined in, and the program that the student is part of, and so on. And then some of the methods could be the courses that the student has enrolled in. So that needs to interact with the course class, for example. And then, what else? I don't know. So let's say the list of events that the student has participated in, and so on. So once you define this encapsulation, we also talked about this public and private visibility modifiers, right, in the last class. So you can now put in these visibility modifiers against each of these attributes and methods, and that is the way to interact for the clients or things that are outside of this class. So let's say there is another class called faculty. So the only way for the faculty class to interact with this, or the faculty object, so to say, to interact with the student object is through these methods that are exposed as public. So if there are, let's say, 10 methods, and out of them 7 are public and 3 are private. So by that you are saying that the only way to interact is through these 7 ways, and they cannot interact in any other way. So there is a fine-grained control over how the state of the object is changed, for example, and how interactions happen through these interactive points. So that's about encapsulation. Is that clear?
Yes,
so
sir.
I gave a brief overview. Yeah. So in the last class, we also discussed some examples. So we'll be again looking at a few examples in this class.
Sir?
So I can talk about encapsulation here. Yes.
Sir, what do we mean by wrapper?
Wrapper. Oh, so I gave, so wrapper is, so something that you use to cover something, right? So let's say in the case of your phone, you have the phone case, which will cover all the electronic circuits inside the phone. So in the case of object-oriented programming, you have the class. So the class acts as a wrapper. So it will cover or it will bring together the methods and the attributes. So another example that I gave is that of a set. So you have, let's say you have a set of animals. So that's an animal class, but let's say take a set of animals and the set contains different elements such as cat, dog, monkey, uh, say donkey, pig. So all these are animals, right? So those are all the elements of the set, which is called animal. So now all these are, and they are called a set because they all share similar characteristics. So in the sense that all of them have legs, all of them have hands, eyes, mouth, and so on. So they all share similar characteristics, and we are bringing them together using the name called animal. Right? So the animal acts as a wrapper in that example. So here I gave the example of student. So if you have a student class, that itself will act as a wrapper, so it will cover or encapsulate or wrapper. I don't know. So it will wrap around those methods. So it's, let's say there are 3 methods and 2 variables. So the class will now wrap around these 5 different things, which is 3 methods and 2 variables. And once you encapsulate them, the only way to interact them is through these public modifiers or visibility modifiers. So let's say among the 3, 2 are public and 1 is a private method. So you can only interact through these public methods, right? So that's the wrapper or the encapsulation. So there will be more examples in this lecture. If you have more questions, you can ask me when we go over the code, right?
Excuse me, sir.
Yes.
Sorry to interrupt. I had a doubt regarding something you posted in classroom. It was like regarding final. So we can apply.
Finals, yes.
Yeah, we can apply final modifier to a variable, indicating that it would never be changed in the future. But
Yes.
there were some examples which I found by taking on the net that you can even apply final modifiers to a class. So what do you mean by that?
Oh, final class. Okay. So we will be discussing these things later on, right? So we will be talking about, for example, inheritance and say polymorphism, overriding, and those kinds of things. So we'll be discussing about the final classes as well. So we can come back to it. So you can. So if this question doesn't get answered in the next couple of class, then you can get it back to me again. You can bring it up again.
Okay, thank you, sir.
Is that okay?
Yes, sir.
Okay. Yeah, thanks. Okay, so let me get started with today's lecture. So we'll be talking about class and objects, and let me first start with the design of the program. So whenever we are given a problem, so that can be, say, either a competitive programming problem, or say, so when you go for when you join a company and go for a job, right? So you'll be given a requirement document. So that talks about what they expect from the system or the program that you're building or the application. So the very first step would be to analyze what they want. So in that, by analysis, what we mean is what should be the inputs, what should be the output, what are the ways in which this application or the system should be tested, what are the expected say workload, or load. So let's say you're deploying your application. It's a banking application, and it will be used by, let's say, all the people in a particular bank. So each branch might have, let's say, 50 employees. But if it's something that's deployed on the web and it's a popular website, then you'll be getting a lot more hits, right? So you'll be expecting something like thousands of users to be using the application at the same time. So depending on the load, you will also be talking about the architecture and these kinds of things. Right? That's why the first step is to always analyze what is the problem and what is the expectation. So in terms of say runtime, how fast should the program be, and how much memory should it take, and as well as the corner cases that are mentioned here. Right? That is the first step. So you start with the analysis. So once the analysis is done, you think of, at least in the object-oriented point of view, you think about the design. So you start thinking about the different classes, and then how should the classes interact with the other classes, and what. So that indicates the relationships here. That's and then the each of the attributes. So attributes are nothing but the variables which capture the state of the object. So you should also think about the ways in which one object interacts with the other. So that is through the methods, which is also called as message passing, right? So that's the second step. So you start designing the entire solution in terms of the classes and their interactions. And the third step is the implementation, which is the programming part. So it is supposed to be one of the least creative steps here, because by the time you get to the implementation, you should already be clear on so all the other things, like what are the classes and the properties, what are the inputs and outputs, and so at this step it should only be converting these things, let's say in the form of diagrams, into the syntax. So you already know the syntax, let's say, of any particular programming language. So you use that to actually write the code, because you have considered all the cases beforehand, such as the corner cases and the possible ways to test and even debug your code. So there should not be too much issues while implementing it, right? Because you have already thought through all the different cases that your application should handle. So that's the implementation step. And then you have the testing phase, where which is again very important. So you look at all the possible ways in which the users can attack your application, so to say. So what are all the different possible inputs, and for each of these inputs are the output as expected. So these are things that you will be testing in your in the testing phase. So you try to reduce the errors and make it error free, so to say, from your point of view. So it's always hard to eliminate all the bugs, but from your point of view, at least you have tested it as well as you can, and you made it error free, right? So that's the testing phase. So the reason to go over all these different steps would be is because we'll be talking about at least the design part here. So once you analyze it, you need to design it, right? So we'll be talking briefly about the design part, and then how the implementation can correspond to the design part. Okay. So we'll start with the analysis. So the first step is to identify the. Okay, first is to understand what the requirement documentation is talking about. So if you don't, if you have any questions, you should always go back to the client who made that request, and then check with them, right? So what do they want, and what do they mean by a few features or the requirements that they put in. So after that is done, you start looking at it from the design point of view. So you need to identify the classes and the responsibilities, so to say. So what is it that each individual class would be handling, and how do they interact with each other? So in order to identify the classes, one of the heuristic, so to say, is to look for nouns. So you go over the document, and then you make a note of all the nouns in the document. So these nouns can be actors, so to say. So these are specific things that can perform the tasks, which we call as objects, or they can be certain events. So something like, let's say, your graduation ceremony. So there's a graduation ceremony coming up, and then we can talk about what are all the events and the talks that will be going on as part of the graduation ceremony, right? So there can be a document on that, and you will be looking at all these lines in the document and then identifying the nouns. So the nouns are, so actors and events are part of the nouns, right? But there can be other nouns as well. So the next step would be to identify the responsibilities. So these become the methods. So these become the classes and the objects. So depending on how specific it is. So let's say if it is very specific, like a cat, dog, monkey, so then it becomes an object. But if it is a little more general, like animal, bird, amphibian, so then that can become a class. So so the first step is about identifying the class and the objects, and the second step is about identifying the methods and also the division of responsibility, right? So it's a good idea to not to overload these classes with too many responsibilities. So by that I mean, let's say, so you shouldn't be combining, let's say, student and course, even though they are related to each other. Student class would only be dealing with the students, and course class would be dealing everything with respect to the courses, right? And they can interact with each other, but they should not be combined. So every class should have a very specific responsibility. It should not have too many responsibilities, and that is one of the good practices, right? So that is what makes up good design. So you need to take care so as to not to overload each class with too many responsibilities. So the best way to look for responsibilities, again, this is a heuristic, is to look for verbs or the action terms. So these describe the responsibilities, right? So for example, student has enrolled in course A, or you can say student one, say John has enrolled in two courses which are AP and OS. So enrolled in is an action word or a verb, and John is a noun, and you have two other nouns, which is advanced programming, which are the course names, advanced programming and operating system. So in that sentence, you identify the nouns, and again, operating system and advanced programming are specific, right? So those become the objects. So if you want to make it more general, you will have a course class, and it will have two objects in this case, which is AP and OS. And again, John is specific. So John is a student, but it's a instance or a specific type of student, right? So that's why, again, John would become an object and student would become a class. And enrolled in means one of the action words. So it should be taken in as a method. So here is an example. So you have a requirement document, and it has a bunch of text, right? So it talks about product, and product having a name and a product number, and the product number is represented by a barcode. So you go over these document carefully, and then the first step, like I said, is to identify the classes, and the heuristic that we can follow is to get to know or recognize the nouns. So the highlighted portions are the nouns. So you have user here, which is one of the nouns. You have product, and then the characteristic. So you have a name and product number, and there are again multiple nouns here. So you have barcode, product, error, message window, and so on. I think those are, yeah. So these are all the nouns. But the caveat here is not all nouns. You don't need to make all the nouns as either a class or an object. So that depends on the design. So for example, you may not be interested even in the transactions. So that can be ignored. Or you may not be in your application, you may not be interested in a summary report. So that can be ignored. But if you are considering, or if the requirement is to make a transaction or have a summary report, then you need to also consider this as part of the design process and create a class or a object. Right? So we already talked about some of these guidelines. So one of the important ones is the division of responsibility. So don't overload, say one. So don't make, let's say, one class which deals with everything. Right? So that is very similar to your procedures. So in procedures, let's say if you have only one file where you put in all your 20 functions, then it will be hard to differentiate or make the interactions between all these functions. So even in the procedural style, you should not be having too many responsibilities for each function. So you see to it that each function has um, only limited responsibility. Let's say ideally only one responsibility, and it will deal with that and it will pass it on or take the help of other functions if it has to solve more complex tasks. Okay? So it's very similar here. So each class has a limited responsibility and it can take the help of other classes to solve more complex tasks. And the other important thing is the naming conventions. So do follow consistent names. So I think ideally it should be Camel Case. So Camel Case is imagine the hump of the camel. Right? So let's say you're putting more than one word together as the name of a class. So then the first letter of each word should be a capital letter. So for example, going back to the previous one, it's let's say we have a class called summary report. So there should not be any space. You concatenate these two, and then you make S capital and R capital. So that's a good naming convention. And for the attributes and methods, the naming convention should be lower camel case. So which means you start with, if there are multiple words as part of the method or the attribute, you combine them together, but except for the first word, all the other first letters of all the other words should be capitalized. So if you have barcode, so B should be small, but C should be capital. And if you have error log, for example, as an attribute or a method, so E should be small, but L should be capital. Right? So those are the good naming conventions. And yeah, so this is again how you start. So at the analysis phase, you only look at identifying the classes and the responsibilities. Right? So we don't need to look at the relationships. So how will one class interact with the other class? So that part we leave it to the design phase. So in the analysis, we only look at identification of classes and objects as well as the methods. So there's one more example. So in this case, we are looking at a scenario where we are logging into an email account, online email account. So the customer will put in the username, password, and they'll click on the button. So is there a question? Okay. So again, as a first step, you identify the classes, which are nothing but the nouns. So they can, so like I said again, nouns can be either classes or objects or things that you don't want to consider at all in your design. So again, we'll look at a few highlighted portions, and these are the nouns. So there may be other nouns, but we are ignoring it for now. So the second step would be to identify the verbs. So verbs can be methods. Again, like I said again, not all verbs can be or need to be converted to methods. So you can ignore a few and consider only the ones that are required for you. Or you can also combine a few, and then they can have. So one method can have, say, let's say one responsibility. But if that one responsibility covers more than one verb, then you can also ignore other verbs in those cases. So the highlighted portions which are in a different color here. So the yellow ones are nouns, and this is the verb, right? So the first verb is click, then you have display, enter, and then the click the OK button, validate. So these are the verbs. So you identified the classes now and the verbs, which are nothing but the methods. So with this, the first step of analysis is done. Right? So now you go into the design phase. So in design, you are worried or you look into the relationships. So how should one class interact with the other class? And also what are all the different methods that should belong to a class. So in the previous step, you only identified the nouns, right? So for example, click can go into customer or account. Display can go into one of these classes, or there can be a new class as well. So those are the things that you need to consider during the design phase. So when you identify the nouns, they can be either objects or classes. So if you identified objects, right? So if you think some of them are objects, then you can look at grouping them together by giving them a common name. So in the case of the animal class, so if you come across all these different types of animals like dog, cat, and so on, then you can try and so you can take them as objects and then group them together as a class, which is animal. And if you start noticing that a class is taking up too many responsibilities, then you can break it up into smaller classes. Right? So that's the second one. And you can start assigning these responsibilities, which are nothing but the methods, to each of these classes. And then you start thinking about the interactions. How will one object interact with the other object of a different class? So in order to simplify these interactions, right? So let's say you're given a requirement document that spans multiple pages. So let's say it's a 50-page document. So there'll be many different classes, and you might have identified lots of different responsibilities as well, and verbs, so which are methods. So in order to keep track of all these classes, it's very hard if you are just looking at them without drawing it. So if you draw it, you can visually look at all these interactions. Right? So that's the advantage of what are called as sequence diagrams. So you draw these classes and then the interactions between them. So the way we draw it, we'll be looking at it in the next few slides. But there is, in the next couple of lectures, we'll also be looking at what is called as UML, which stands for Unified Modeling Language. So it's also a mechanism to design these interactions between these classes. So it is an improved version. So it is better to design using UML, but we'll be covering it in a later lecture. Right? So for now, we'll start with the sequence diagrams. Okay, here is an example again. So this is an example of logging into online email account. So you have the username, password, and you log into it. So we identified these nouns and verbs. Right? So on the left hand side, you see a list of all the nouns, and in the right hand side, you see a list of all the verbs. So like I said again, you don't necessarily have to make all of them as classes. You can ignore some of them, especially if that responsibility is already captured by different class. Or you can convert some of them might turn out to be objects and not classes. And same holds for methods. So you don't have to necessarily consider all of them as methods. Right? Okay, so let's start with the sequence diagram. So for the classes and methods, there's no. For the classes, you have these rectangular boxes. And this is the timeline. Timeline of the interaction is represented by this bar, so to say. So now you start with the interactions, which are verbs, and the methods. So these interactions are represented by this arrow. So this is the edge that connects these two nodes, so to say. And then you have the label on top of the edge, which is nothing but the verb. Right? So this is how you can represent it visually or graphically, and it will be easy to notice all the interactions. So the first step is to go to the home page and you click on the login button. Then the login page appears. Right? So at the home page, so it's the responsibility of the home page to display the login page. right? And the login page is now in some way returned to the customer. And once the login page is available to the customers, the customer would enter or put in the credentials. It is nothing but the username and password. So the credentials part is an interaction that happens between the customer and the login page. And once the credentials are put in, the customer would click OK. And then the other class would be, which is the email account that comes into the picture. So once the customer has put in the credentials and clicked OK, the next step would be to validate those credentials. And in order to validate those credentials, the login page has to interact with the email account object, because the idea is that would hold all the details related to the email account. So once the validation happens, it will return to the customer with some message saying that either it is the credentials are okay or they are not okay, so it needs to be re-entered and so on. Right? So this is how you display or depict the interactions among all these classes. And once you look at it, it becomes easy to know what are all the interactions, right? So that's the advantage of these sequence diagrams. Okay. So yeah, I already talked about all these things. So you have the rectangular boxes, which are the classes, and then you have the labels on the edges, which are the methods. So this also shows the direction. So there's the direction of there should be a direction associated with each arrow or the edge. So that shows the direction of the message. So in terms of object-oriented programming, so you can assume that the object belonging to login page would call the method on the object of the email account.
Excuse me, sir.
Yes.
So won't the lifespan of login page be as long as that of email? Matlab, it should have been longer. Matlab, login page and email account should end simultaneously.
Okay, so why is that? So let's say you have a login page. Once the login page has captured the login details, the purpose of the login page is done, right? So the life
But the user called, matlab, when we interact with the site on bank, we interact with the login page and the details are returned to the login page itself.
Yes. So okay. Let's say I think you are talking about the case where the login credentials are wrong. Is it? So if there are two cases, right? So you validate it, and if the validation fails, so that means the credentials are wrong, then it can either go to the login page, or it can, let's say if it's highly sensitive and you are given only one chance to enter the credentials, then the customer would simply be, or this request would be rejected and the customer will not be allowed to enter. But if you want to, let's say there are 3 attempts that you can make. So in those cases, yes, so if the validation fails, you go back to the login page again. So that depends on your design, so to say. So you can either say give a message to the customer saying that the validation has failed and the credentials are wrong, and you can put a button, login button again, which goes back to this, right? So after this fails, it can start again here. So click the login, and everything can restart. Or you can redirect the customer to the login page automatically, and then ask the customer to enter the details. So that's so that depends on your design. Right? Any other questions so far? Okay, so let me move on. So the second good practice while designing these, so the first one is the limiting the responsibilities part, right? So don't overload a class with too many responsibilities. That's the first one. And the second good practice is to have this cohesion between the methods. So that means, let's say you have 5 methods in your class. So all these methods should be related to each other in some ways. So they should be talking about the class in general. So they should be related to the class in general, and it also be related to each other. So it cannot be two very different methods. So that means if they are very different, that means you are putting in too many responsibilities into one class, right? So that's a sign that you should probably break it up and then maybe consider having two different classes. So for example, you have in your, let's say you have a login page class. So one of the methods can be enter credentials, and the other one could be click OK, right? So if you have validate also as part of the login page, uh, then it may not make sense, because validate would now require the password and username details also. The login page ideally should not be having, right? So login page is only supposed to collect those details. So it should collect the credentials, and you should pass on those details to some other class, which can then validate it. So if you are having validate also as part of the login page, then it's a sign that maybe you are having too many responsibilities, and it's time to split up those responsibilities. So that's the question part. Okay. So these a
Sir,
yeah. Yeah, is there a question?
excuse me, sir.
Yes, yes.
So in the cohesion part, it means that we have to make the less number of methods.
Um, okay, so the responsibility principle applies to the method as well. So one method should not be having too many responsibilities. Ideally, it should be having only one very specific responsibility, and then the other responsibilities should be split among the other methods, right? So you can create new methods, or you can also create private methods, which are like helper methods. So in that sense, the responsibility principle applies to it as well. But if the class is having very specific responsibility, then there can be less number of methods. But if it has, let's say, slightly bigger responsibility, then there can be more methods as well. So there is no, so let's say if you have 10 methods, probably that's okay. But if you are having, say, 30 or 25 or 30 methods, then you should relook at the design. So maybe that is not a good design, and there are too many things that the class is handling. So in that case, you need to split it up. So don't, yeah, so having too many methods is also a red flag. So you should definitely look at it. But one of the first red flags is the number of responsibilities that it's handling, and then whether there is cohesion among these different methods. Right? Did that answer your question?
Yes, sir. Thank you.
Okay, thanks. Okay, so let's move on. So you can take some time here. So let's say, so this is a picture of a taken in a classroom, right? So you have whiteboard with lots of material written on it. You have an instructor, and then you have a bunch of students who are listening to the lecture. So you can take some time. Let's say you can take 2 minutes, and then come up with the classes that you can spot here. Right? So in the previous couple of slides, we looked at text, and then we identified the nouns. So in this case, it's an image. So why don't you go ahead and identify some of the classes, and you can put them in the chat. So I'll look at the chat, and then we'll discuss after you put in a few of these possible classes, right? You can take 2 minutes. Okay, so yeah, these are good. So I'm looking at the chat window and I see lots of good nouns and things that can be taken as classes, right? So I'll talk about a few of them. Um, so obviously you can see an instructor here. So instructor can be a class. It's a noun. You have students, so that's obvious. That's one obvious one. And then you have the blackboard, uh, the chalk that was used, the classroom, right? So whenever we need to, when it comes to allocation of classes, we need a classroom. So that can be a possible class here as well. So some of them have mentioned, so I'll take a few examples, right? So this is part of the requirements document, which I didn't provide you with. So for example, fan, AC and tube lights. So depending on what you want to model, so you can either consider them or you can ignore them, right? So let's say you have an automated means, like a smart classroom, right? Where the lights are switched on at the class time, and they'll be turned off either at the end of the class, or if the class ends early, then they'll be turned off when everyone leaves the room, right? Or if the class ends later, so again this holds. So by if everyone leaves the room, then the lights would be turned off, right? So unless you have a smart classroom and you are trying to model that, fans, lights and tube lights are not important, right? So those are things that could be ignored. So the other thing that I noticed is boys and girls, right? So although again, so that depends on the requirements. So let's say you want to have that fine-grained analysis, like how many boys are there in a class, how many girls are there. So then you need to differentiate. So if you are not doing that, so let's say that again depends on the requirement of the application. So if you are only concerned about this at the level of students, then you can have only one class, which is the student class. So irrespective of their gender, so you don't need to have two classes. Or the other one could be you have the student class here. That's right. So you can have the gender as an attribute of the student class. So yeah, those are some of the So yeah, I agree. So I think all of you have identified the good number of classes, nouns, right? Nouns, so to say, in general. So there can be objects and classes. So that's good. So let's move on to the next one. So those are about, so far we have talked about some of the design aspects, right? So how do you identify the classes, objects, and the verbs, which are the methods, and the interactions between them, so which we can represent using these sequence diagrams. So now let's talk a bit about these objects and say, for example, how are the objects created, how are they represented in the memory. So those form the next couple of our next part of the lecture. So let's talk about these creating these instances. So objects are nothing but the instances of the class. Okay, let me move this elsewhere. So each class acts as a blueprint. So for example, here we have a robot and we have blueprint of this robot. So that talks about the so what are all the functionalities of the robot. So what are things that the robot can do? How can you control the robot through the state? And what are all the interaction points? So you can you interact with some specific commands, or is it through a remote control? Or can you talk to the robot in free form language? So these are all the things that this blueprint talks about, right? So once you have the blueprint, which is in our case, it's the class, the robot class, you would need to instantiate it. So that means you need to create these robots. So let's say you want to create 5 robots, and these 5 robots need to interact in different ways to achieve a common functionality, right? Let's say it's a home, it's an old age home, for example, and these robots are supposed to help the people who are in the old age home. So they are supposed to get the medicines on time, or they're supposed to help the people to go from one place to the other if they are disabled, for example, and they're supposed to monitor them. So these are all the things that the robots can do. Now, there can be more than one robot who can handle all these things, right? So you need to create instances of this robot class. And the way to create these instances, which are nothing but the objects in our case, is to use this syntax. So you have new, which is a keyword, and then the robot is the name of the class, followed by these parentheses, and it will end in the using the semicolon. So these parentheses can optionally have some arguments, or it need not have any arguments. So in this case, there are no arguments, but in some cases there can also be some arguments, right? So this is nothing but we call it a constructor. So it's the official term that is reserved for a special kind of method, right, which we will see in the next couple of slides. I'll just okay. So let's say you have a class called dog. So now all the different types of dogs, or even if all the different dogs would be instances of this class called dog. Right? And this is the syntax of the constructor. So you use as the name says, right? So if you want to build an instance, you should be using the constructor. So it is used automatically. So whenever you say new robot, the constructor gets invoked. And again, going by the syntax, this is nothing but a method, but it's a special method. So it's called special because you don't see a return type here. Generally, all the methods will have return type. So return type is nothing but what is the output of the method. So let's say the method may have some certain inputs, which in this case is 0. So there are no inputs. And every method is supposed to do something, right? Do some work. And whenever the work gets completed, it needs to return the output of the work or the outcome of the work. So that the return is represented by the return type. So if it is, for example, adding two numbers, then the return type can be either an integer or a floating point number, right? So, so constructors don't have a return type. They simply have the visibility modifier, and it's generally public. So if it is private, then there is no way to build the object, right? So it has to be public. And so we also have some examples of code or methods that can be part of the dog class. So you have the bark method. So this is the keyword again, which talks about the return type. So void indicates that the bark method is not returning anything. So although it may do some work, or it should be doing some work, but it is not returning the result, right? Returning the result to the caller. So you have the caller and the callee. Caller calls the method on the callee, and if there is a return type, then the caller can make use of the return, whatever gets returned by the method. But if there is no return type, then there's no way to get to know what, or it means that there is nothing that can be returned, right? So okay, so one of the methods is bark, and the input here is the number of times the dog should bark. And there are two other methods, which is eat and wagtail, right? So the dog has, so in this, if you look at these methods, the dog has three responsibilities. One is to bark, the second one is to eat, and third one is to wag the tail. And we have the methods corresponding to each of these three responsibilities. Yeah, we already talked about this. So the constructors should not have any return type. And that's how that's one way to recognize a constructor. And the other way is that the name of the class should be the name of the constructor. Right? So that's the other way, second way to recognize that this is a constructor. And the way to instantiate or create an object is
Sir, I have a doubt.
Yes.
Sir, actually, you just mentioned that constructor can't have a return type. So I have a question that why we can't declare a constructor where it would have a return type? Like, why any language doesn't support this?
So okay, so okay, although we say that there is no return type, right? So implicitly something is getting returned, which is the reference to this new instance. So for example, the way I'll be showing it in the next couple of slides, right? So there is a left hand side to this as well. So this is the right hand side part. There is an assignment operator here, and then you have the left hand side of the assignment operator. So you have dog, for example, you have the name of the dog. Let's say you have, I don't know, tiger. Right? So dog, tiger is the name of the dog. You have the assignment operator, and then you say new dog. So what we are implicitly, or what is happening implicitly is an instance is created somewhere in the memory, and the reference gets assigned to the name tiger. So the reference is getting returned, but except that we don't have to specify that here. So something is implicitly getting returned here. Right? Does that answer your question?
Thank you, sir. Yes, sir. Yes.
Yeah.
Thank you.
Okay.
So I have a doubt as well.
Yes.
Yeah, so since objects can't access the private method, so what if the constructor contains calls a private method? So will it be called when the object is created?
Yeah. So okay. So the question is inside the constructor you are calling a private method, right?
Yeah, exactly.
Yeah. That's okay. So the only way to call private methods is internally from other methods.
Okay,
So you
and
cannot call it from outside of the class. So that's the
yeah,
only way to call it, and yeah, that's possible.
okay, thank you.
Excuse me, sir.
Yes.
If in the previous, in this class dog, if I have public static void main, and in that I declare an object of this class, and then use that object to call a private instance, will it be called?
No. So you cannot. So okay. So this method, main method, is that outside of this
Yeah.
class or is it
No,
inside?
it is inside the class.
Oh, inside
Because
the
in
class.
Java
Okay.
we have to make a wrapper class.
Yes. So yeah. So if it is inside, yeah, then you can create an instance of dog.
Yeah, and then
So
use that instance to call a private attribute. So suppose just above the constructor, I write private some attribute, and then call that attribute with the object of dog class.
no. So okay. So the only way to so let's say you have a method called breed. Sorry, not method, but attribute called breed, right?
Yeah.
So you can directly use the breed attribute within any of these methods. So you
But
don't
not
have to
in the main,
say,
right?
say, let's say the name of the dog is Tiger. So you don't need to say Tiger dot breed. Yeah, and yeah, you
That
shouldn't be
I know.
using that in the main. So the proper way of
Yeah.
using that is through the getter and setter. So you can say Tiger dot get breed, and it will return the breed.
Yeah, because these methods I'd be calling with the help of an object. So I'd write obj.eat, and then the eat function will be called, and eat knows that it has been called with the help of an object. So I don't need to use that to refer to the attribute. That is why I can use the attributes inside those
Yes,
functions.
yeah, that's
So
right.
I
You
was
can
asking
directly use it.
specifically
Yeah.
about the main function.
Yeah, it's the same. Right? So you shouldn't be using I don't know Tiger dot breed there.
Inside main.
Yeah, inside main.
Thank you.
Okay.
Sir, I have
No,
a doubt too.
Huh.
Sir, when we define a constructor, sir, the function of constructor is basically to initialize the attributes of class, right, sir?
Yes.
Sir, but Java by default initializes the attributes automatically. So why does we require such constructor?
Okay, so in the next couple of slides, but you are right that the purpose of the constructor is to instantiate or initialize the attributes of the class. But if you leave it to the default, if you don't do the initialization, then it will be initialized to the default values. Right? For example, for int it can be 0, but you may want to initialize the int with 5 and not 0 or -1. And in the case of the previous class, right, dog. So if you have a breed string, the default initialization could be empty, but you may want to say that the default breed is some specific breed, like say bulldog, whatever, or something like that. So we'll also get to know one
Thank you,
more reason. So one of the attributes can also be objects of other class. Right, we'll see that in the later part of the slides. So if there are objects of the other class, then the default initialization of that is null, what is called as null, which you may not want to do, right? So, but yeah, we'll talk more about it in the next couple of slides.
Excuse me, sir.
Yes.
Sir, we have made an object here, django.
Yeah.
Yeah, if I do django.name, then it will be accessible or not?
Django.name. So if it is outside of this doc class, which is the case here, then it will not be accessed, or it should result in an error, because it is private, right? So private attributes or anything that is private can only be accessed from within the class.
Okay, sir.
So that's why it's important to have these getters and setters that we discussed last time, and they should be public.
Excuse me, sir.
Okay.
Hello.
Shall I go ahead? Yeah.
Sir, I wanted to ask whether we can create an object inside the class.
Yes, go ahead.
Sir, I wanted to ask whether can we create an object inside the class, like this django. Can we write this line inside the class?
Yeah, you can do that. So you can create inside the same class, you mean?
Okay, sir.
Okay. Okay, so let's I'll move on. So so I was talking about this earlier, right? So you have a new instance of the doc that is created, and the name has been given here, Django. So you have a doc whose name is Django, and then you create an instance of that name of that class. So here this is the constructor that is shown here, and here you have the name, the breed. So there are two constructors here. Okay? So one constructor takes an integer argument, and the other constructor takes the string. So there can be multiple constructors, and there can also be a constructor which has empty parameters. So there can be a constructor which is empty, right? And there can be constructors with multiple different parameters. So for example, you can also have constructor that takes 3 parameters: name, breed, ID, and rego is the registration number of the dog. So you can have all these 3 as inputs. And for initializing the static variables, you need this separate initialization block. So we will talk about static most probably in the future lectures, but static is something that is common. Okay, so all these 3 variables, they are specific to each object, right? So object 1 will have a different name compared to object 2. So object 1 may have Django, and object 2 is could be called Tiger, for example. The breed ID could be different and the registration number ID is different. But in the case of static, if you keep something as static, then it is common for all the objects. So this is like a class level variable, right? Not an object level variable. So these are all, these capture the state of the objects, the first three variables, right? The last one, which is rego counter, which is the registration counter, it captures the state of all the objects together, right? So that's why you need a separate initialization block. It cannot be part of the constructor, because constructor is gets invoked for each object, but this is not a object level variable, right? So that's why you need a separate initialization block, and you can start this counter, right? So the counter starts with 0, which is the default value of static ints, and whenever the constructor gets called, this also gets called. So you have this initialization which keeps happening. Right? So the execution order, so you can also take this as a homework. You can type it in and then put some print statements and get to know. But first the initialization block gets executed, then you have the constructor, and then the statements within the constructor. So the constructor calls other methods, and that method also gets executed. Right? So that's the order of the execution here.
So I had a doubt.
Yeah.
So when the constructor gets called, how does the static initialization block get called in the? I mean, what's the order of execution here?
The order of execution, like I said, so it's the first thing that would be called is the initialization block, and then the constructor gets called.
Okay.
Yeah. So you can also try this on your laptop, right? You can take this code and then put it in. You can also add some print statements here and then check what gets printed, which one gets printed first, and you can do it for 2 or 3 objects.
Excuse me, sir.
Yeah.
On the previous slide, what is this 20 doing?
Oh, yeah, okay, that's a good catch. So I skipped that part. So this is a keyword again, and it refers to the current object. So, for example, in the case of Django, this would refer to the Django. And if you are creating one more instance, say dog, and the name of the dog is Tiger. So dog Tiger equals new dog of, in the double quotes you have Tiger. So in that case, this refers to Tiger. So whatever instance on which the constructor is called, this refers to that particular instance, right? So when you say this of 20, this is a shortcut to call the constructor, which is this one. So this of 20 would call the first constructor, which is public dog, in the parentheses the integer, because 20 is an integer. It will call the integer constructor, right? So first it will call this particular constructor, and then it will initialize name to whatever input was given, whatever parameter was passed. Is that clear?
Yes.
So sorry. So in this particular case, right, you are passing a string. So this constructor would not be called. So the order of execution would be first the initialization block, then this particular constructor would be called because you are passing a string, and this is a constructor that corresponds to the string argument. Within this constructor, you are calling the other constructor. So 1, 2, and at this particular line, it will go back to line Y, and then line X would get executed. So it's line Z, Y, and X. So that should be the order. But like I said, you can try this out on your laptop and then check it as well. Okay. So So just like other variables, right? So let's say you want to create a new variable called age. So you have int age equals to 25. So the first part of that on the left hand side is the type or the type of the variable. So in the example that I gave, the type of the variable age is integer. So you say you start with int age equals 25. So on the right hand side, you have the value which you assign it to the name of the variable. So the same thing happens here. You have, even if you want to do it for the classes, right? So the dog is the name of the class, Django is the name of the object, and then you have the constructor which will create the instance and it will assign it to the Django name, right? So the type name equals, sorry, this is the assignment operator value, and it should end with a semicolon. So there are two types. One is the basic data types, which is int, float, double, string, and so on. And the other type is the custom type, which is what you can create using the classes. So dog here is called a custom data type, right? Or user defined data type. Both are same. So the way you declare it and do the assignment is on the left hand side you have the type followed by the name, and on the right hand side you have the value. So that value can be for the basic data types, it can be the simple values like 25 or some string like this, Django, or it can be more complex. For user defined data types, you generally have the constructor. Right? So that's how you do it. And this is called a variable because we can keep reassigning the value of the variable. So int age can be 25, and later on in the program you can change the value of the age to 30, right? Because it's a variable. And if it's not a variable, it should be declared as final, which means it's a constant, right? So that same thing holds true for even user defined objects of user defined types. So Django can be reassigned to some other new dog, and it is okay to do that. Okay, so in the next set of slides, we'll be talking about how these.
Excuse me, sir.
Yeah. What?
If we simply write Django 2 equals, dog Django 2 equals to Django, so would it copy all the attributes, or do we need to explicitly copy the attributes?
Okay, so we'll be coming to that. So I can explain that only after talking about this slide, right? So that's the copy by reference and value. So let me complete this slide, and then I can answer this question. So there are two ways in which this information is stored. So by information, I mean the value of any variable, right? So one is by value and the other one is by reference. So if you have basic data types like int, double, string, float, so it is stored using the value. So imagine that you have a box, and the name of the box is the name of the variable, and inside the box you have the value. So in this case you have 9, right? So which is stored right inside the box. So that is, the value is directly assigned to the type. So the other way of storing this is through the reference. So somewhere in the memory, there's a dog that gets created. So this memory location would have information about all the attributes, what are the states of the attributes. So that means the values of the attributes, and so on. And then this Django is simply a reference to that location, memory location. So let's say this is stored in memory location 1001. So now Django simply is a pointer, or it's a reference to that 1001. So here the attributes, the values of the attributes, for example, just to simplify, right? We have, let's say there are 2 attributes of the dog class. One is the breed and the other one is, let's say, the age. So it doesn't happen that it is not the case that the breed is, let's say, bulldog, and the age is, let's say, 5. So those values will not get stored here, which is the case here. So on the other, so the way it's done is, let's say there is a memory location 1001, and the reference to that gets stored here, right? So that's why it's called a pointer, or a reference to the actual place where the values of the object are stored. So that's the difference between storing the values versus storing the references. And the reason we do that is in primitive data types or the basic data types, the size of this is well known. Right? So you already know beforehand what is the size of the integer, the size of double, and so on. But you do not know beforehand what is the size of each object. The objects can be of any size. So there, if you some of the classes can have 5 attributes. Some of them can have 3 attributes, and these 3 attributes can be different data types. Some of the class can have 7 attributes, and so on. So in order to, this is very much like your linked list, right? So you can create arbitrarily large linked list, and you simply store the head information here. But in this case, it's not like that. So you have the exact value, and that will get stored here. So that's the difference between value and reference. So there's a level of indirection here, right? Because it's stored somewhere else, and it's simply a pointer to that particular location. So is that clear? Value versus references. Yeah.
So I had a little bit of I had a doubt with static. It's like
yes.
So like static indicates like that particular instance is being shared by all of the objects.
Yes.
But like for example, if I have to create something like this, let's say if in a constructor, how do I define such a variable which would have the function for the following? Like if the user does not give me a dog name, I keep it as a default dog name. Something like, let's say, in that case, if I pass Django, then it will change its name to Django. But if I don't pass anything, it will keep its name to, let's say, Mikey, something like that.
Yeah. Okay.
So if I declare it as static, then it will change it for all the objects. But I want to declare it as a default thing. So as like a default base reference for all the classes. How do I do that?
Okay, that's a good question, but okay, so that's possible in Python, right? So you have something called a default parameter. So you can, so here you can, yeah. So again, this is in other language. I'm not sure. So at least in the older Java versions, this was not possible, but I'm not sure if this can be done in the newer Java version. So what you can do is, or what is one of the possibilities is, you have this assignment operator here itself. You have int breed equals, let's say, bulldog, or in the example that you have, string name equals Django. So if there is no other name that's passed, then it takes it as a Django, or if that is not the case, then by default, whatever you pass is used. But that is in Python. So in Java, the something equivalent that you can do is the default constructor. It does not have any name, right? Sorry, it does not have any arguments. So in that case, you simply call the default constructor and you put in the name of Django in the default constructor.
So Java, like I looked it up, Java does not have
the default parameters. Okay.
So
default arguments.
Okay. Can I do something like this? Like instead of that,
let me just complete. So then you can use the default constructor, right? So in the default constructor, you simply assign the name Django, and unless someone calls this specific constructor, which is the dog with the name, you always have Django for every object that you create. Okay, I'm done. So yeah, what was someone was?
Yeah. So I was saying, like, cannot we initialize it like on the very declaration of name, like can we write it as like in this case private
Oh, here
string,
itself.
yeah, private string name is equal to Mikey, something like that.
Yeah, you can also do that. Yes. So that's equivalent. Yeah, you can do that. And then you can say that name equals Django, and that will hold for all the new objects that are created. Or you can, I think a better practice would be to put that in the default constructor. So even then, unless you call the dog with dog constructor with the name, every dog would have Django as the default name.
Thank you, sir.
Okay. So this value versus references is clear, right? So you can treat, like I said, the simple analogy would be treat it as a linked list, and the head of the position of the head with the memory location of the head is stored here. So that's how you can assume it, right? And in the case of the storage of value, you simply write you directly have the value in that particular against that name, against the variable name. Okay, so here is an example. But maybe I can go back to the question, Shruti's question, right? So the question was, if you assign, say, Django to dog Django 2 equals Django, equals in the sense assignment operator, then what happens? So here you are simply doing it through reference, right? So if we use that, the same example, you have Django 2 as well, and you have dog Django 2 equals Django. So both of them will now have the same reference, which is, so you now have two pointers pointing to the same memory location. So that's what happens. So if you change one, there will be changes in the other as well. Does that answer your question? Okay.
Yes, sir, but like if we have to have another object with the same attributes, I don't want to refer to the same thing.
Yeah, then
like I
you
have
have
to
to
manually do it.
yes, yeah. So the way you do it is you can say dog Django 2 equals new dog. So that means a new memory location would be created. Now Django 2, you can set the values using the getters of Django. So for example, you can say Django 2 dot set breed equals Django dot get breed. So you use the getters and setters and set the values individually. So then the memory locations are separate and they are independent of each other. Or there can be there's one more mechanism, which is the constructor can take the argument of an object, right? So it's called copy constructor, so to say. So one of the other constructor that you can have here is public dog, and the data type here is dog. So public dog 1, for example. So if you can pass Django to this constructor and it can do the copying within here. But the way it is done is again through getters and setters. So it's not, it's just that you are pushing the responsibility inside the dog. Okay, so let me go over this example, and I think we are almost towards the end of the lecture time. So I'll discuss this example and then maybe I'll stop. So, okay, let's say you have this pet shop, right? And it has lots of pets which it sells, but for now, let's take it only sells dogs. So we have dog class, so let's assume that it sells dogs. So you have this one method which is called test Django, and you have the constructor of that, right? So as part of the constructor, you can also call other methods within the class, or even or within the methods of this class. So here you ended up calling the test Django, right? So whenever a new object gets instantiated, it calls the constructor, and this constructor in turn calls this method. So this method is now creating the dog, and it's also calling the other methods, which is bark, eat, and wagtail, right? So, but one of the things that it does is it also calls this eat method. But feeding the dog may not be the responsible of the pet shop owner, right? So he can, or he or she, the pet shop owner can uh, delegate this responsibility to a different person, and that person can be the groomer, dog groomer. So let's say every day in the evening or in the morning, someone comes in. That person who is the groomer can feed all the dogs and go back. So this happens, let's say, every day or once twice every day. Once in the morning, once in the evening. They come and they feed the dog. They take care of the dog and then they go. So in that sense, you are delegating, or the pet shop owner is delegating that responsibility to that of the groomer, right? So if that is done, then we can move this eat method to the dog groomer class, and that is what we'll be doing here, right? So we'll be splitting up the responsibility. Pet shop owner only takes care of a few things. The rest of the other responsibility of which is of feeding the dog would be taken care of by the dog groomer. So yeah, so if the dog groomer wants to get to know which dog to groom, then the dog groomer need to know the details of the dog, right? And that is why you have this uh, instance as part of instance as the argument of the method called groom. So the takeaway from here is that you can have basic data types as the arguments, and apart from that, you can also have these user-defined data types or custom data types, which is the dog, also as the data type. As the parameter. So the dog groomer class now has a groom method. So it has a constructor. This is the default constructor, which has no arguments, and then it has the groom method, which needs the details of the dog, which needs to be groomed, right? So that's why it takes the instance of the dog as a parameter. So yeah, it's the type and it's the name. So which is same as other methods. So you have the, for example, int read ID. In the same way you have dog, which is the type, followed by the name of the variable, which is shaggy dog. So now, how do you call the groom method? So inside the pet shop, you want to call the groom method, right? So you already have the test groomer, which is another method here. So you create the dog Django, and then you should also, in order to call the groom method, you need to have the object of that method. You need to have the object, and only then you can communicate through this method to the object. So you create a new object, which is dog groomer, and then you call the method groom with the instance that you created just now, which is the Django, right? So now you are passing in the details of the dog that needs to be groomed to the groomer who should be taking care of the dog. So now the groomer has the details of the dog, and they can take care of the dog, right? So that's how you do it. So I'll stop here, and then we can continue in the next class. But if you have any questions so far, yeah, please let me know. Yeah, in the meanwhile, I'll just check the chat messages.